Hey everyone, welcome to Women Who Code San Francisco's backend study group. Just a few instructions on what to expect from the session. You can go to the next slide. Yeah, so a little bit about me. I'm Prachi Shah. I'm the host, volunteer director at Women Who Code San Francisco. And I started the backend study group a couple years ago, where we teach, we have a team, we teach backend engineering concepts every month. And a little bit about Women Who Code. Our mission is to empower diverse women to excel in technology careers. Our vision is a tech industry where women and historically excluded people thrive at any level. Like I mentioned, Backend Study Group it's 2 years old now, and we have done a lot of great events. We have our recordings for past events on YouTube, and also our presentations are all on GitHub, links to which I will share at the end of the session. I would also, today's topic is like cloud computing, and our instructor is Harini. So Harini, take over.
Hi, thanks, Prachi. Hey, everyone. Welcome to Backend Study Group series. If you are a regular participant, thanks for joining us again. And if you are new, welcome. It's going to be an exciting series. So yeah, keep coming back. So my name is Harini Rajendran. I work as a senior software engineer with a company called Confluent. I'm based out of Chicago. I started volunteering with Women Who Code during the pandemic, so about 3 years back. I started with volunteering with the algorithms and interview prep study group, and then I switched to the backend study group series and started presenting sessions with Prachi and a few other folks. Yeah, it has been an exciting journey so far. Today's topic is cloud computing 101. So if you're someone who wants to know the basics of cloud computing, who wants to understand what cloud computing is, how is it different from on-prem, what are the different ways in which cloud services are deployed, why do we even use cloud computing? Why not just stick to the traditional on-prem solutions? Where all cloud computing is being used, and all those things. Like today's session is a good fit for you. I'm not covering any advanced topics in cloud computing as such. Throughout the session, if you have any questions, feel free to post it in the chat box. I'll also keep an eye, and Prachi would also keep an eye, and we would either answer it as we go, or I can answer all of them like towards the end of the session. And if I don't know the answer to any of your questions, I'll make sure I go look it up and provide the answer in our Slack channel. So if you're not there in our Slack channel, Prachi will share the link to it. You can join that as well. So let's dive in. So whenever you hear about cloud computing, like this is one famous quote or a saying that I've always stumbled upon. And it reads, there is nothing called as cloud, it's just someone else's computer. So at the end of the day, like the word cloud computing sounds so fancy, but then at the end of the day, it's the same set of computers running the same set of software, the operating system and everything, just that we don't own the computer, and the computer doesn't sit inside our office or our home, but rather it sits in someone else's real estate. So it's just a matter of ownership. So there are multiple levels when it comes to ownership, and based on the level of ownership, we can there are like different cloud deployment models which we'll be seeing which we'll be seeing in the further slides. But just keep that in mind that when we say cloud computing, it's nothing but the same set of computers, just that it's being hosted by someone else. Pretty much that's it. So how is it different from the traditional on-prem sort of deployment that we have been using for like that was actually in use before cloud computing, right? So when we talk about on-prem solution, it's nothing but a set of computers, or you can call them as a network of servers. They're all self-managed. So when I say self-managed, you own it. Like you go purchase the hardware, you go purchase the storage and everything, and you set it up in your home or in your office or in your own data center, you take care of it. One of the downside of that is you'll have to pay, there is a huge upfront cost because you'll have to buy everything, even though you don't need it, you still have to, you'll still have to like pay a huge amount upfront to set it up. And let's say suddenly like you are starting a business, let's say like one computer was enough, and then it's, let's say it's holiday season, and suddenly you want like 10 computers just for the holiday season, and once the holiday season is done, you can go back to one. But you don't have such flexibility when you use an on-prem sort of deployment model, because you'll have to either like pay for the remaining 10 and purchase the whole thing, and then it's again like a huge cost that you are paying, even if you need it only for the holiday busy season, right? So that's where cloud came into picture, and that's why it became so popular, because now it's still the same set of computers, same network of softwares, but instead of you managing it, it's actually managed by some third-party company. Some of the well-known ones are, Amazon, Microsoft, Google, etc. And you can access these computers or these servers which runs the application over internet. So all you need is just internet. And another big advantage is you don't have to pay a huge upfront cost, but rather these companies follow something called as a subscription model. So it's like Netflix or whatever, right? You only pay for what you use. So today, if you're using one computer or one server, you would be paying just for that one server. Let's say for the holiday season, 1 month, you're using 10 servers, then you'll be paying for that. And once you scale them down again back to one, then you'll be paying just for the one server. So this is super flexible, and you can scale up and scale down as you need. And you don't have to maintain or manage any of the infrastructure yourself. So this is what cloud computing is, and these are all some of the advantages. So as you see here, cloud computing, they take care of networking between all the different softwares. Usually like software applications are hosted. Since you're accessing these applications over internet, security is very important in the cloud, because let's say you store some mission critical data like health data or financial data or whatever, right? It's very important that the cloud providers provide enough security so that we can trust them and give them our data or give them our application and whatnot. They also take care of storing the data for us. They do all sorts of, they provide infrastructure to do some sort of business intelligence on top of our data. So cloud computing is a huge world in itself, and there are like just so many different things that you can do using it. As I said earlier, there are like multiple deployment models or service models, I would say, in cloud computing. And the main difference between, they're called SaaS, PaaS, and IaaS. So the main difference between these three different categories is the level of ownership. So SaaS stands for software as a service, PaaS, platform as a service, and the third one, infrastructure as a service. So I'll explain what each and every one of them is in detail in the next slide. So the first one is software as a service, right? So as the name defines, when you say software as a service, you just access an application or a software that's running somewhere in the internet, and you just use them. That's it. For example, let's say you use Gmail or Slack or Zoom, anything, right? Microsoft Office 365. All these applications, if you see, you don't manage the code, you don't run the server in which those applications are running. All you do is you just open internet, go to Chrome, type gmail.com, and bam, you have the application in front of you, out of the box, ready to use. So such kind of softwares that are like offered as a service to you, it's called software as a service. You don't have to worry about backing up your emails periodically, or you don't have to worry about running maintenance of your software. You don't have to worry about updating the software or whatnot. All that is taken care of by the company who is actually like hosting and running the service. So all you have to do is you just use it. So you literally like own nothing here. Also, it's very reliable, because these companies often promise like 99.9999% availability, which they usually like, we call them as service level agreement. So they promise that if you use the software, it would be up and running, 99.999 times, which is like almost always. So these are some of the examples of SaaS services. Some of the common types of SaaS services are, messaging software, which are like Slack, Facebook Messenger, Microsoft Link, and all of that, and online collaboration software like Canva, Google Office, Google Doc, Google Spreadsheet, and all of that. I also think that there are a few like human resource HR related software that are also available as a service in the cloud. There are some finance related software that are again like also available as services in the cloud. So you don't have to worry about deploying the HR software or the finance software, managing it and all of that. You can just log in and use it. Salesforce is something for, inventory, order management, customer management and stuff, right? So that could be one example. So I've just listed a few examples here. So this is software as a service deployment model. Next, one level above this is platform as a service. So software as a service is, you don't write any code, you don't manage any application, you just use the application that's offered as a service to you. But let's say you go one level above, saying like you have your own custom application. Let's say you have your own website, or you have your own some backend server that you wrote. But you just want some platform where you can, go and deploy this the website or the backend software without worrying about, load balancing, auto scaling, monitoring and alerting and all of that. Because otherwise, if you have to do everything by yourselves, it's a lot of work. It will take a lot of time for you to figure all of those things out and get it right? So that's where platform as a service comes into picture. There, you are given an application development environment as a service, so you can log in to the application, like to the platform, and then you can just upload your code there. You can build and upload the code, and you can just deploy the application that you wrote. The advantage here is that platform usually takes care of all the things that I mentioned earlier, auto scaling your application up and down based on the load, monitoring and alerting, like if your application is unhealthy, it would monitor, like you can monitor it, it would alert you and all of that. So one advantage of using these platforms as a service is that now there is faster time to market. You can just focus on building your app, which is what actually adds value to your business. And you don't have to spend any time managing the infrastructure, because the whole platform is given to you. And all you have to do is just upload your code and press the deploy button. You are not like worried about the server going down and all of that. All of that is managed by the platform that is provided to you as a service. So these are some of the examples: AWS Elastic Beanstalk, Google App Engine, and SAP Cloud. So for example, if you take AWS Elastic Beanstalk, it actually provides whatever I just mentioned earlier. Let's say you have you wrote a backend service in Java. All you have to do is just upload the jar to AWS Beanstalk from their console. And then if you just plus deploy, you can select, okay, which all region you want to deploy it in. What is the auto scaling policy? Do you want monitoring and alerting on your application and all of that. So it's just at the click of a button, you get everything that's needed to, deploy and manage your application, and you get to do all of that at a much faster rate by using platform as a service. So this is the second kind of cloud deployment model. And the third one is like, again, one level further above, it's called infrastructure as a service. So here, it's literally like you are using someone else's computer. So it's like they are providing the whole infrastructure as a service to you. Just that the computer or the storage or the hardware, it doesn't sit in your real estate, but it's sitting in someone else's place. Again, you can buy them on demand. If you want one server today, and if you want 10 servers tomorrow, you can buy them, and then day after tomorrow, you can scale it back down to one server. And as I mentioned earlier, there is no huge upfront hardware cost, even though you are just using like someone else's hardware and someone else's computer, you still pay for it only for the time you use it. And the same software, the same server or the same computer can be accessed by multiple users. So there is like efficient resource utilization and resource sharing across multiple users. So these are some of the advantages of infrastructure as a service. So here you take care of the platform, like you pick the OS, you take care of updates, you take care of roles. If a node goes down, what happens? You handle all of that, but just that infrastructure is provided by like the computer or the storage that is provided by AWS or Azure or Google Cloud or whatever cloud provider you use. So this is infrastructure as a service. Like many of the bigger companies, like for example, the company that I work with, Confluent, we heavily use infrastructure as a service because we just get Kubernetes clusters from AWS and AWS Google Cloud, and we take care of everything, like what OS to deploy in that, what applications to run, how we monitor those applications, how we scale up, scale down, all of those is handled by us, and we don't depend on the cloud providers to do that for us. So yeah, that is infrastructure as a service. So these are the three different kinds of cloud deployment models, and it's purely the ownership, that's the level of ownership that's different between the three of them. And that is beautifully described in this image, if you see. So the first one is on-site, the on-prem solution, where all the blue boxes are the ones that you manage as a user. All the red boxes are the ones that are actually managed by someone else, let's say by the providers. So if you're going with an on-prem or an on-site solution, you literally own everything. Like you purchase the server, storage, you set up networking, you take care of installing the OS, installing the middleware. You are responsible for deploying, updating, managing the application on top, and also the data, right? So you'll have to see, okay, if you lose the data, how do you recover it? How many replicas of data you need, and all of that. So literally like 100%, you have to take care of everything. That's why everything is in green. If you see software as a service, literally everything is managed by the service provider. All you have to do is just log in from Chrome or some browser, and then just use the application, for example, Gmail or Zoom or whatever, right? If you think about platform as a service, again, they would provide everything that is needed to run an application. All you do is just deploy your application and manage the data that is generated by your application. Those are the only things that you care about. And infrastructure as a service, they would give you the computer, but you take care of everything on top of it. What OS should you run on the computer? What middleware? What applications you would deploy, and how would you be managing those applications and the data that it generates and all of that. So this one slide actually sort of summarizes what we saw in the past in the past 3 slides. So these are the different sort of cloud deployment models, and based on your use case and whatever, like you can choose to use whatever makes sense to you. And in addition to those three, there's also this other deployment model called function as a service, which has been getting some traction in the past few years. So function as a service is the most simplistic deployment model. So here you don't even worry about applications. You don't even worry about servers. That's why it's also called as serverless sort of deployment. So here, all you do is you just write functions. So if you're familiar with any programming language, you can imagine what a function is, right? A function is just a snippet of code that does some specific job. So you just write functions and you deploy them as a service in the cloud. So that model is called function as a service. And this is more commonly used these days in edge devices and in Internet of Things. For example, let's say edge devices could be like weather sensors that are deployed across the city, and Internet of Things are all the smart home devices that we use these days, like Alexa or whatever, right? Amazon Fire Stick or whatever, right? So let's say all these IoT devices and edge devices, they actually generate huge high volume events. So if there is some function that has to be invoked for each event, let's say when you measure the temperature, some event has to happen, which could be like sending the data to some server, or notifying someone, or let's say you want some event-based action, then the function as a service model perfectly fits there. Because it's super lightweight, because all you have to deploy is just a snippet of code. So even if you have to invoke it like millions of time per second, it would still be okay, and it's easy to scale at that level. And yeah, you don't have to, as a user, you don't have to even worry about managing any sort of application. And you can purely literally focus on the core business logic of the function, and you can just quickly deploy it in minutes. So all the 3 top cloud providers, AWS, Google, and Microsoft, all of them, they have an equivalent of this function as a service. In AWS, it's called AWS Lambda. Google calls it Google Cloud Functions. And Microsoft, they call it Microsoft Azure Functions. Any questions so far? Yeah, so Manju is asking, for example, function as a service is used in earthquake alert. Yeah, that's a pretty great example. That's one of the edge use case that we can think of, because there would be these sensors that are literally deployed across earthquake prone areas, which are constantly monitoring and gathering information. So yeah, if an earthquake is detected, that's a great event that has to be notified and raised, right? So yeah, that could be a good use case for function as a service. You're right. And then so those are the different kinds of deployment models, right? And then another differentiation, I would say, is the type of cloud services. Usually we call it private cloud, public cloud, and hybrid cloud. So let's see what those are. So public cloud is the most widely and most commonly used type of cloud service. So there, the cloud service that's offered, it's just offered over internet. So anyone who has internet access in the world can access those services. For example, again, going back to Gmail or whatever, right? They're all offered in public cloud. it has the highest level of efficiency because more people use it. It's the most commonly available. So if the more the number of people are using a particular resource, the more efficiently it is used, because like the resource is shared amongst multiple people, so it's utilized at its maximum. And compared to the other models like private and hybrid, public cloud offerings are usually the cheapest because it's just available over the internet, and also economy of scale comes into picture. When more people are using some particular service, obviously it would get cheaper and cheaper because of that reason. But again, this is considered the least secure compared to the other two deployment models, because again, it's available over the internet. Anyone can hack it. Anyone can, DDoS your service. So if you are like a bank, or if you are a government agency, if you are Fed, then you most probably would hesitate to use public cloud, or even like if you are a hospital, you would most probably hesitate to use public cloud because of these security threats compared to the other models. So this is called public cloud. The next one is private cloud. So private cloud, as the name suggests, it's usually like the service that's offered to a particular organization in a private network. So only the folks, or only the servers that are within that organization can access that particular service. So it's not accessible via the internet. So hence it is considered the most secure. But at the same time, you can imagine that it's the most expensive of the three deployment models for the same reasons, right? It's used only by one organization, so there's no economy of scale compared to the public cloud. And also, like, obviously, it's more secure. So if you are getting a better security, then obviously you pay more for it. So that's why private cloud services are usually like more expensive. So if you're a small startup, or let's say a small organization, like probably like a private cloud might not be a practical solution for someone who is just getting started because of the cost reasons. So in those sort of use cases, that's where hybrid cloud comes into picture. So hybrid cloud, as the name suggests, it's nothing but like a combination of private and public cloud, and even like on-prem services. The way how this transition usually happens is customers would actually be running all their services on-prem, and then at some point they start thinking about cloud. So they would first try out cloud by moving some of their non-critical workloads to public cloud. And as they get more familiarized, and as they start trusting cloud more, they might be like, okay, hey, we can give a try with the private cloud for even our critical applications. So they move a part of their workload with sensitive information to private cloud. Another way that I've seen companies use private cloud is for disaster recovery. Let's say I run an on-prem software or an on-prem solution, but for some reason, if my data center goes down, I need a backup somewhere, right? So I've seen companies use private cloud as another replica, so that it's a disaster recovery solution. Even if you lose everything, even if an earthquake happens and all your servers are crushed, you would still have like a backup somewhere in the cloud, in private cloud, in some other region, so that all your data and application and everything is up and running. So that's another use case that I've seen where companies use this hybrid cloud model. Again, it combines the best of both the worlds. You can pick and choose what to run in public cloud, what to run in private, what to run on-prem. And even like another angle of approaching hybrid cloud is, you can choose to run the same application across multiple cloud providers like AWS, Azure, and Google Cloud. Like that's what we do in my company. So if AWS is down, our software would still keep running in Azure and GCP. So that's another way of looking at hybrid cloud, where you deploy the same thing across different cloud providers. The biggest advantage of this is like portability of workloads. You can choose where to deploy what. It gives you more agility. And compared to like pure private cloud solution, here cost is a little bit moderate, because you pick and choose what you want to deploy in private cloud, and you can choose to deploy the rest in public cloud or even on-prem, which are usually like which gives you the flexibility to decide on the cost, like how much you want to spend, where you want to spend, and all of that. So this is hybrid cloud. Just to sort of show the differences between them in a tabular format. The auto scaling, the environment, as I mentioned, is for public cloud, it's publicly available resources that are accessible over the internet. For private cloud, it's private networks, and for hybrid, it's a mix. Auto scaling is usually high wherever public cloud is involved, because of economy of scale. There are like thousands of servers that these companies are managing across multiple different regions. So you get that scale when you go to public or hybrid cloud. Whereas if you use private cloud, it's usually one network. We face it all the time. We are like, we can only spin like 255 servers in this particular region, in this particular cluster. So auto scaling can get limited when you use private cloud, and it's not like as high as it is in public or the hybrid cloud. And security wise, again, like public cloud is good. It's okay in terms of security. It still is good, because if cloud is not secure, then no one would be using it these days. But if security is your topmost concern, then you could either use private cloud or hybrid cloud. Reliability wise, again, I think it's pretty straightforward. Public cloud has comparatively the lowest reliability compared to the other two models, because again, it's available over the internet. It's susceptible to hackers and DDoS and all of that, compared to the other two. Whereas the private cloud provides the highest reliability, because it's just virtually a private network that only you and your organization can access. Cost wise, again, public cloud is the cheapest, private cloud is the most expensive one, and hybrid cloud falls somewhere in between. And who is it for? Usually I would say like companies like government agencies, and all the companies that are running like mission critical applications, like healthcare industry, financial organizations. They usually opt only for private clouds, like especially like federal customers. They won't even look at public or hybrid cloud solutions. They are pretty adamant about using only private cloud, because of the kind of data that they handle. Whereas if you are a company who's hosting some website or something which doesn't have any like mission critical data and such, you are mostly like okay with running your service in private cloud. So depending on the criticality of the application and the data, you can decide which of the three deployment model works for your particular use case. So we saw like what is cloud, what are the different types of deployment models and all of that. And now let's see, like I covered bits and pieces of this here and there. Why do we even like use cloud computing, right? As I mentioned earlier, it's cost effective because we are like using like a pool of people or a pool of different companies are using or sharing the same resource. So if the better the resource utilization is, the cost, the cheaper the cost is. So it's usually a lot cheaper than running and maintaining your own stuff. So it's more cost effective and it's more reliable, because these companies provide strong SLAs and your service is guaranteed to be up and running most of the time. You also have this flexibility with respect to scaling. As we spoke earlier, you can scale it up and scale it down as and when you need, and at like a much quicker rate. It's flexible in the sense you can access it from anywhere. All you need is internet or your access to your private network, and you can access it from anywhere, and anybody can access it from anywhere, in the sense multiple people can access the same server just with the help of internet, right? And then you don't have to worry about updating the platform, updating the software. Let's say if you're using SaaS or if you're using PaaS, they take care of maintaining the infrastructure for you. They take care of doing the updates, the backups, the maintenance, and all of that. So literally, like, you can offload all of that, all of those operational sort of stuff to someone else, and you can purely focus on the logic and the application that adds value to your business. And security and privacy, obviously it's not, it can never be as secure as you running the solution on-prem by yourself. But then at this scale, and with so much advancement in cloud technologies, all the major cloud providers are making sure that they take security very seriously for all the services that they provide. So you don't have to worry about attacks or attacks by hackers or anything of that sort. And then same thing, it's time saving. The time to market is super quick. You can just focus on the important stuff. And another big advantage that I've seen is the tech support. So let's say you suddenly have a use case where you want to use Elasticsearch for something, for some new project, right? You might not even know what Elasticsearch is, or you might not have the expertise to spin up and run like a big Elasticsearch cluster by yourself. So that's where using Elasticsearch as a service in the cloud comes in very handy, because all you have to do is you go to the console and say, hey, I need one Elasticsearch cluster, and it comes up and running. And if you see any issues, if it's not working or if it's very slow, you don't need the expertise to go and dig into it and see and figure out what is wrong with Elasticsearch. All you have to do is just open a support ticket to Amazon, and then a tech expert from the Amazon side would come in and they would see, okay, what's wrong with this cluster? Should it be scaled up? Should we use a different instance type? Should we provide more memory? Should we add more disks? Should we partition the data differently, or whatever the problem is? The tech support person, the subject matter expert there, would do it for you or would ask you to do it, and you don't have to break your head trying to figure out all of it. And this is applicable to all the different kinds of softwares that's available as a service, right? So you literally don't need any kind of in-house expertise, and all that is available to you and provided to you by these cloud providers. So these are some of the advantages on why we should consider using cloud instead of running and maintaining everything by yourself on-prem. And what are some of the common use cases and where all cloud computing is used? If I have to say it in one word, it's used everywhere for everything. But then if you have to dive a little bit deeper, individuals use it. Like, we use it all the time, right? Even like this particular meeting is happening on Zoom, which is again a software that's provided as a service in the cloud. Similarly, like small businesses, like startups or small companies for running their website in cloud, like small companies also use cloud. Even like large organizations with thousands or even hundreds of thousands of employees, they also heavily use cloud these days. All the educational sectors like schools, universities, they use government, so like federal customers use cloud, like not as much as these other institutes, but they are also like starting to use cloud more and more these days, and health industry. So cloud computing has become like ubiquitous, like almost everyone is using. And the statistics says that 50% of the businesses as of today in the uses, in the cloud uses, in the US uses cloud in some capacity. And some of the common use cases are, database management. Like I was just talking about Elasticsearch, right? So you don't run Elasticsearch, or for that matter, you don't run PostgreSQL or anything on-prem. Rather, you just use it as a service in the cloud. A very common example, well-known one, is email servers. We all just use email like Gmail, Yahoo, whatever that's provided as a service in the cloud. E-commerce like Amazon, eBay and whatnot. Website hosting, GoDaddy, and all of those services. File storage and sharing could be Dropbox, Amazon S3, Google Docs, and whatnot. Right? Global collaboration, Slack, things like that. And as I mentioned, like it's also used in sort of disaster recovery kind of use cases where you host everything on-prem and then you use cloud as a backup, or even in cloud, you store like two replicas, or you have the primary one in one region, and then for disaster recovery, you store the backup in some other region, so that if region one goes down, you have the whole backup up and running in region two. So these are some of the common specific use cases for cloud, and to also gives an example of who all uses cloud these days. Just some statistics here. So as of today, these are the top 5 cloud providers. I think it's not surprising that AWS takes a lion's share there with 34% of the market share. And apparently, like Microsoft Azure used to be only around like 10% back in 2015, and they're quickly catching up, and they're up to like 22% of market share as of today, followed by GCP. I think GCP was also somewhere around 4 or 5% in 2015, and they are also like increasingly taking more and more market share as we with time. And outside of US, Alibaba Cloud in China is the next largest cloud provider, and they have about like 6% of the market share, and I would assume like most of it is within China. And another interesting fact is, if you are aware of AWS, the most commonly used top 3 services from AWS are, AWS EC2 instances. EC2 instances are nothing but servers. So you just literally get servers or computer from AWS saying, hey, I need a computer or a server with, let's say, 5 gig memory, 32 cores and 100 gig disk with this much bandwidth. And they have like literally hundreds of different types of instances. So based on your use case and how big or small of a computer or a server you want, you can just pay for them and buy those. So those are the EC2 instances. And AWS RDS is the relational database service. It's called equivalent of Postgres, but PostgreSQL that's offered as a service in the cloud. And then the Amazon S3 simple storage service is their blob storage. So you can literally store any blob of data in S3 and share it with others who has access to S3 as well. So these are the top 3 most widely used AWS services, and these are the most top famous cloud providers in the world as of today. So if you're someone who's thinking about, switching to cloud specialization, like there are large number of like AWS certification courses that are available. So if you take those, then it could come in handy if you are interviewing, because as you can see, more companies use AWS. So if you're familiar with AWS related technologies, then it'd be easier to get a job or switch to a role where they heavily use AWS services. And same is applicable to Azure and GCP as well. Yeah, so let's see, like, okay, now till now we were focusing on, okay, what is cloud, how do we use it, how is it being used today and all of that. But if we want to, spend a little bit time in understanding the future of cloud computing, it's actually like really exciting. So what are some of the things that we could see in the future on the cloud front, right? First one is multi-cloud are on the rise. So as I mentioned earlier, like even till today or up to a few years before, when companies move from on-prem solution to cloud, they would usually like pick one cloud provider, let's say AWS, and they would just deploy everything there in AWS. So what ended up happening was they were logged into AWS, and let's say some region in AWS goes down, then their service it won't be available and they would be hit, right? So that's where like these days companies are trying to be more intelligent and they are doing like multi-cloud deployments. Okay. Do you have any suggestions for resources where to learn from scratch? Manju is asking. I can actually uh, provide some in our Slack space later today. I don't have anything on top of my head as such, but I can do some research and I can provide with some resources on Slack. I'll make a note of it. Yeah. So multi-cloud are on the rise, right? So that's what my company does also. So currently what we do is we package our software, like my company's software, in these containers, and these containers are like ubiquitous. You can run them everywhere. You can run them on AWS, you can run them on Azure, GCP, or Alibaba, or wherever. It doesn't really matter. So that way it gives us the flexibility to deploy it anywhere without getting locked into a particular vendor. If a particular vendor it's not flexible, and if they are quoting too much price, or if we see that their service is not good, we always have the flexibility to just not use them and use someone else instead. If we set up our architecture in such a way that it's multi-cloud from day one, then there is no enormous switching cost from one vendor to the other because it's there inherently in the architecture of the system. Whereas if you design everything and deploy everything thinking about just one vendor in mind, then obviously if you have to switch everything from AWS to Azure, let's say, then you might have to rewrite the code, you might have to you might have to pick a different service, and all of that hassle will come into picture, and there would be like huge cost associated with it. So that's why companies these days are very cognizant about designing and keeping their application in such a way that it's multi-cloud compatible and you can just actually deploy it anywhere. That leads to more adoption of Kubernetes. If you're not aware of Kubernetes, you can read about it. It's like a software that's used to manage containers. So we can think of containers as like a boxed, lightweight server, I would say. So you package your application, you package it as a container, and you can deploy it anywhere in any cloud. And Kubernetes is just the orchestration layer that's used to manage these containers. So as multi-cloud is on the rise, as more and more companies are using and managing applications in the form of containers, obviously Kubernetes adoption is also going up hand in hand with that. And one interesting fact with respect to storage is it is estimated that by 2025, we would be storing like 200 zettabyte of data in the cloud, 200 zettabyte of data globally. So 1 zettabyte is 1 billion terabytes. So you can imagine the scale of it. And it is estimated that 50% of it, just like 100 zettabyte of data, will actually be stored in the cloud, which is like huge. So by 2025, there's going to be like a wealth of knowledge that's available in the cloud, which leads to the next point, which is cloud-based artificial intelligence system. If you really think about it, all these AI, ML systems, they actually need a lot of data because they learn using the data, they process a lot of data. So as more and more data is available in the cloud, then obviously AI, ML, everything would also have a proportional growth in the cloud. So that's also something that we could expect going forward. And as we are offloading more and more data and applications to the cloud, all the cloud providers these days, they are also focusing more on data privacy and security. They are making sure that no security or privacy issues are compromised. And there are like more and more investments along these areas as well. I'm just looking at the chat. Okay, there are no questions as such. Okay. And again, like nowadays, like with time, like more and more educational institutions and healthcare industries, banks, even Fed, they are all also are adopting like cloud. So we would see that more of them would be using cloud in the future. And as we see, like more and more businesses use cloud, obviously it would have like a direct impact on the economy of the country as such, right? So like to an extent, you can see that the more all these cloud computing technologies are actually like indirectly also like having an impact on the economy of the system as a whole, as more and more businesses use it and more businesses are influenced by it. For example, all these businesses use these intelligent AI ML solution to change the way how they do business, and that in turn impacts the economy directly. So you can see how the adaptation of cloud has such huge impact in the world, even if it's not like obvious right at the beginning. And some more future like interesting things that we could see in the future. I was just talking about edge computing and Internet of Things, right? So with this advancement in networks like 5G and stuff, which is like really good at handling intermittent data, there are like the edge devices are getting more and more powerful, and it's getting more and more widespread. Like as someone mentioned on the chat, even like earthquake sensors, temperature sensors, whatever you take, like that has to be deployed in remote regions. They are like being used more and more with time because of these advancement in technologies, and in turn they are producing large volumes of data, which goes back to the thing that we saw in the previous slide, where like we are producing like humongous amount of data. So edge computing will be like will have more traction in the future because of cloud growth in cloud and all these technological advancements. Similarly, like Internet of Things, there are, as you can see, there are more and more smart home devices these days, and it's only going to go up. More and more smart vehicles with all of this, autonomous vehicles and stuff getting popular, and smart industries where the whole industry production chain, it's all smart and there are no human beings involved. It's all run by robots and stuff, right? So yeah, with the advancement in technologies, like we can see that these Internet of Things would also grow, and that would in turn like cause like a huge explosion of cloud computing services being used in the future. Again, like as more and more IoT and edge computing devices are used, it's a perfect use case for serverless computing, as we discussed earlier. So we could also see like more and more serverless computing sort of deployment model getting famous in the future, and like more and more companies might be using this sort of a deployment model rather than running and managing like their applications. Yeah, so that could also like be on the rise in the near future, like over the next few years or so. Pretty much that's it from my side. Today I have listed all the resources that I used to put together the slide deck here. We will be uploading this particular session's presentation in YouTube probably in the next couple days. Once it's available in YouTube, I can post the link to it in our Slack channel. We also have some pretty exciting sessions coming up next couple months. We have a SQL query one-on-one, big data pipeline one-on-one, and Ruby on Rails one-on-one coming up. Yeah, pretty much that's it. If anyone has any questions, I'm happy to answer. And Prachi has shared a lot of useful links. You can take a look at them. What is the tech stack required to become a cloud engineer? I would say familiarize yourself with any programming language like Java or whatever, right? Because that's what you ultimately use to write code, and then familiarize yourself with, let's say you can pick AWS, and then you can start looking into, you can start looking into some of the certification courses that the AWS provides. You can start familiarizing yourself with some of the services that AWS provides. So I wouldn't call it a tech stack, but I would rather call it as familiarizing yourself with the services that's provided by those cloud providers. I would say if I want to familiarize myself with AWS, probably what I would do is I learn Java, and then I'll read about EC2, RDS, and S3, which I just mentioned. So let's say you read about those three, you figure out how to buy an EC2 service, deploy your code, connect it to an RDS instance, and store something in S3. And if you can put all of this together and successfully run something, by then you would have already figured out all the basic workings of what a cloud is, how AWS works, and all of that. And then you can start building from there. You can start using more and more advanced services. You can familiarize yourself that way. In my personal experience, I have not taken any certification courses or anything as such. I've always based on the use case and the needs of the project, I've always did some research and figured out, learned, dabbled with it, and then started using it. That's how I have been learning cloud. So based on the use case and what problem you have in hand, you read about it, find the best service that's available out there, and just see how you can use it. Yeah. But yeah, if you're totally new and if you need some basic idea, then probably doing those courses from, Coursera, Udemy, and all of that would really come in handy for sure. But yeah, the basic fundamental level, just familiarize yourself with a good programming language so that you can code using that. At the end of the day, if you're deploying some code in cloud, that's the basic thing that you need to know. And also, if you're using if you're using SQL, obviously you don't have to manage SQL by yourself, but then you should know how to write SQL codes or whatnot, right? So that's applicable. If you're using Elasticsearch, probably you don't have to understand how Elasticsearch works, but then you should be aware of, what is Elasticsearch? How is data stored in Elasticsearch? How do I write to Elasticsearch? How do I read from Elasticsearch, and all of that, right? So pretty much it's applicable to any of the cloud service that you use. You need to understand how to use it, but you need not understand how to manage it. Preferred language for cloud? That's a good question. I don't say there's any specific preferred language as such, but Java and Python, I would say that's the most, at least that's what I've been using most of the time. Yeah, so pretty much that would be a good start. You can literally do anything in Java, so. All right. If there are no more questions, then thanks everyone for joining us tonight. You all have a great rest of the day.
Thank you.